In this video, we're going to do a quick verification that the deployment of the NSX to the ESXi host that we did in the previous video, that it went well. And then secondly, let's create an overlay segment, an NSX-based overlay segment that we can then connect VMs to. So for our game plan, we should be able to verify that both ESXi-A and ESXi-B now have a new IP address associated with a tunnel endpoint, and because we used an uplink profile that was part of a transport node profile that said we want to use VLAN 11 and uplink 2, that should all be in place. Now, presuming that these two ESXi hosts are now enabled with NSX and are now host transport nodes, that means they have the ability, if needed, to go ahead and create a tunnel, a Geneve tunnel, between the endpoints of each of the ESXi hosts. And the controller who makes all of that possible is the NSX manager. That's the brains of the operation, including communicating things like MAC addresses and reachability and so forth. All that's done through the controller process here at the NSX manager that the ESXi hosts are working with. So to actually start using that tunnel, what we'd want to do is go ahead and create at least one overlay segment. So an NSX overlay segment, it really kind of looks and feels at the end of the day like a distributed switch port group. So if we have this overlay segment that we've created and both of our ESXi hosts are supporting that transport zone, that means that this overlay segment is then available on each of our hosts to go ahead and attach VMs to. So we can attach VMs here on ESXi-A to this overlay segment, and we can attach VMs here. And even if these two hosts, ESXi-A and B, are several subnets apart, meaning they have reachability via routing, but they are not directly connected to the same exact VLAN, because they can tunnel the traffic between, for example, VM-A and VM-B, and they can tunnel that traffic over the tunnel between those two ESXi hosts, we can make the illusion that these two VMs, A and B, are on the same exact subnet. So for our example, let's go ahead and let's create this overlay segment called overlay segment 10. And for IP addressing, let's use 10.10.0.0 for the actual address space. And then I'll pop in a couple of really small VMs to make it easy. And we'll use the IP addresses of 10.10.0. Let's use .5 over here. And over here, we'll use 10.10.0.6 with a 24-bit mask. So they both believe they're on the same logical layer 3 network. And then as they try to communicate with each other, these two host transport nodes, which are supporting those two VMs, will be able to go ahead and take the traffic, tunnel it, encapsulate it, send it over to the other tunnel endpoint of the other peer, who will then de-encapsulate it and forward the traffic to the final destination. And the way that these two ESXi hosts know about what MAC addresses live where and so forth is all based on the controller, the NSX manager, which is keeping track and populating that information across the NSX topology. So with that in mind, our first step is to validate that ESXi-A and ESXi-B are both successfully brought on board as host transport nodes. And to do that, we're going to go to the NSX manager first. So here at the NSX manager, to check on our host transport nodes, we're going to go to System. And then on the left, we're going to click on Fabric if it's not already expanded, and then go down to Hosts. And then I'm going to go ahead and collapse the left-hand side to give us a little bit more room. And here is our cluster with our two ESXi hosts. So for our first one, which is ESXi-A, it shows as success. That's a good sign. And ESXi-B right here, it shows that it's still working on it. So if we click here, it's still in the process of getting all set up for NSX. So we'll give that a moment to complete. Also, upon closer inspection, I see here that this first host, ESXi-A, even though it says success here, the status says unknown, so it probably also needs a few additional minutes to get all synced up and ready to rock. And so this page is automatically refreshing periodically, but if we want to force it, we can click on refresh here, and then we can open up the cluster, and we can also click on refresh here within the cluster to get the latest and greatest information. So while we're waiting on the final configuration for ESXi-B, let's go to the vSphere client and just take a peek at the VM kernel adapters and the new IP address that it's now using as a tunnel endpoint. So here is our nested vSphere environment. We're on the vSphere client at vSphere.nested. And let's go to the host and clusters view and let's select ESXi-A at .31. And if we go to configure and VM kernel adapters, check this out. Previously, in the previous video, when we looked at this, it had two VM kernel adapters, VMK0 and VMK1, the first one being used for management, the second one being used for vMotion. And check this out. Now that it has the NSX software installed on it and is now acting as a host transport node, it also has this VMK10 logical layer 3 interface, and it has the IP address of 10.11.11.151, which is an IP address that's in a pool that was included as part of our transport node profile, which we then have applied to the cluster. And if we take a peek over at nsx-t, you notice it's not yet done, and so it doesn't yet have that additional VM kernel adapter with the additional tunnel endpoint address, but once it's complete, it will as well. So back at the NSX manager, it looks like ensx-t is still going, so we'll give it a minute to finish. Also, I notice now for status for ensx-a, it now shows the status as up. So we'll wait just a few more minutes and let ensx-b finish its configuration to become a full-blown NSX host transport node. And actually, you know what? What we can do is, because the actual overlay segments are controlled by the NSX manager, we can just let the ensx-b finish in the background, and while it's finishing, let's go ahead and create our overlay segment. And again, think of an overlay segment like a logical port group that exists across multiple NSX transport nodes. So to create the overlay segment, we're going to go to the NSX manager. We'll go to the networking section and simply say we want to create a new overlay segment, and we'll simply name it overlay segment 10 to match our topology right here. And then once it's created, we can then go ahead and logically attach VMs to that logical network segment. And as traffic needs to be forwarded across different ensx-i hosts that are acting as host transport nodes, they'll use the tunnel endpoints and the Geneve tunnel for the forwarding of that traffic. So back at the NSX manager, it looks like ensx-b is getting closer and closer. Fantastic. To set up an overlay segment, we're going to go to the networking tab up on top here as part of the NSX manager. So currently, here it's showing for connectivity that we have 0 segments. Let me expand the left-hand column here. And if we want to create a new overlay segment, we'll simply go under connectivity on the left-hand side and click on segments. So here are currently our segments inside of NSX. And what we'll do is we'll simply click on add segment to create a new one. And based on our plan, let's name this overlay segment 10. So it's just a logical name, and then we currently don't have logical gateways set up as part of the NSX routing and switching, so I'm not going to associate this with any specific gateway. And next, it's asking, okay, for this new segment, which transport zone do you want to associate it with? And because we want this to be an overlay segment as associated with the overlay transport zone, we'll simply select our nested overlay TZ, that's our overlay transport zone, and then scroll down and click on Save. Now it's asking us if we want to do further configuration like DHCP services and other things. For now, I'm going to say nope. All we want is that overlay segment. And let me expand the column here so we can see it. So now we have this new logical overlay segment called overlay segment 10. And if we click here on the network topology, again on the networking tab on top, and then on the left selecting network topology, it's showing us our beautiful overlay segment. So there's not a whole bunch to look at here because it's just a logical segment. There's no services associated with it, and there's no VMs connected to it. So that would be our next logical step, is to go ahead and use it. Now, check this out. Now that we created this new overlay segment, in the vSphere client, that overlay segment is just going to appear like another logical port group associated with the virtual distributed switch. And so to see that, let's pop over to the vSphere client for a moment. So here at the vSphere client, and here I see that ensx-b now has its additional VM kernel adapter with the 10.11.11.152. That's a tunnel endpoint address pulled from the pool that we set up. Let's click on the networking tab. And check this out. For our distributed switch, we have this new overlay segment called overlay segment 10. And there's a little n next to it, and the n is here as well. And that's just representing this was put there from NSX. So we didn't just go in right here under the distributed switch and create it. This was created and implemented based on NSX. And there's the name of the transport zone that this overlay segment is associated with. So presuming that both of our ensx-i hosts are now fully configured and ready to go for NSX, we should be able to put a VM on ensx-i-a and another VM on ensx-i-b, connect each of those VMs to that new overlay segment, and logically those two VMs will believe and act like they are on the same logical network, and any traffic that needs to go back and forth between those two VMs will be shipped over the tunnel. So to demonstrate that, let's go ahead and deploy a couple of really small VMs that'll be quick and easy to test. So to do that real quick, I could right-click almost anywhere here and simply say deploy OVF template, and I happen to have a very small VM that'll be quick to deploy. So I'm going to say local file, then I'll click here on upload files. Then I'm going to grab a template of a really tiny virtual machine. I think it's running Tiny Core Linux, and we'll click on next. And I'm going to name this virtual machine Tiny on ensx-i-a. And then for now, we'll just go ahead and drop this in the discovered virtual machine folder. Click on next. And then we want to place this on nsx-t, so I'll select nsx-t, click on next. And this was deployed in 2015, and I want to give credit where credit is due. So this is where I got it many years ago from cloudarchitectblog.wordpress.com. And check out the size. If we do thin provisioning, it's 17 megabytes. That's like a rounding error. It's so tiny. It has VMware tools installed. It's fantastic. So we'll click on next, and then I'm going to go ahead and place this on the first data store on nsx-t. And even though it's a tiny little thing, I'm going to use thin provisioning to save space where possible. Click on next, and now it wants to know what port group to associate with. And check this out. If we click on browse, look at this. We have an option right here for our overlay segment 10, little N there to indicate that it's an NSX-based segment. So we'll select that, click on OK, click on Next, and then click on Finish. And that little VM is being deployed. So let's go to the VM and templates view, and we'll create a new folder for VMs and templates. And let's call this VMs for testing, and click on OK. And let's also just take a look at recent tasks and running tasks. Great, great. So it's already deployed. And let's go grab that little tiny VM, and we'll put it in the VMs for testing folder. And then before we turn that on, let me also go ahead and right click and edit settings. And I'm going to give that just a little bit more RAM. So it currently wants 48 megabytes. I'm going to go ahead and give it 128 megabytes of RAM. Again, just like a rounding error. And then for the hard disk, I'm also going to give it 128 megabyte. Again, very, very small hard disk. And it's set up as thin provision. Fantastic. And it's connected to overlay segment 10. I'll click on OK. And before I start cloning that for the other ESXi host, let me go ahead and just power it on and make sure it works. So we'll go ahead and power on that VM. And let me just open up real quick web console over there. That'll make it a little bit bigger to see. And it is coming up. So by default, it's not going to have an IP address because a couple things. One is it doesn't have a static IP address configured. And secondly, I don't have DHCP services yet on this overlay segment. So if we typed in ifconfig and pressed enter, yeah, no IP address. Let's set up an IP address real quick. So we'll type in sudo ifconfig ethernet 0, and we'll use the IP address of 10.10.0. And based on our plan, we want this one to be 5. And what is the syntax for netmask? I think it's netmask 255.255.255.0. And let's verify that with an ifconfig. And now we have that IP address 10.10.0.5. Fantastic. So now that that's running here on ESXi-A, let me go ahead and clone it over to ESXi-B. So we'll right click, select clone, and we'll clone to virtual machine. And we'll call this tiny on ESXi-B. And then as far as which folder, we'll put in VMs for testing, click on next. And currently, for the compute resource, it's on the non-NSX host. Look, it says, hey, warning, the network adapter from the VM you're about to clone is using an NSX port group, effectively an NSX overlay segment, which is not accessible. And that's because this host right here, this is ESXi-C, is not a host transport node. It's not enabled for NSX. So if we select host transport nodes, it's going to be less of a problem because these two hosts actually have access to that overlay segment. So we want to put this VM on ESXi-B, which is at .32, and we'll click on next. And we'll go ahead and put it on the first data store on ESXi-B. We'll go ahead and do thin provisioning and click on next. And then just for grands, let's do a customization of the virtual machine hardware just to confirm, and then we'll have it automatically power on after we take a look, and we'll click on next. All right, so as far as the memory and CPU and hard disk, that looks great. And for its network adapter, it's going to be connected to the overlay segment 10. Which is available also here on ESXi-B. So we'll click on next and finish, and that clone operation is on its way. Let's look at recent tasks, and that should only take a few moments because it's a super tiny VM, and it is done. Fantastic. All right, so there it is, and let's click on it, and let's go to a web console, just because that'll be a little bit bigger to see. And based on our plan, we want this little VM to have the IP address of 10.10.0.6 on that same subnet. So to facilitate that, let's do an ifconfig, and it has no IP address at the moment. We'll do a sudo ifconfig for ethernet 0. We want to use 10.10.0.6 with a 24-bit mask, so we'll put that in as well and press enter, and then we'll do an ifconfig just to verify it took, and sure enough. So before we test connectivity between these two VMs, let's take a look at our topology. We currently have our two ESXi hosts enabled as host transport nodes. They both have a tunnel endpoint address. They're both in cahoots with NSX Manager, getting information about who's where and how to reach those endpoints. We have a VM over here that we placed on ESXi-A. We have another VM here on ESXi-B, and they both are connected to that same common NSX-based overlay segment 10. So in the event we went to this VM here and we tried to ping, for example, 10.10.0.6, when that traffic comes into nsx-t, which is our host transport node that's running this VM, it would know, based on the information it got from the NSX manager, it would know that the reachability to get to that destination IP address is over to the endpoint, the tunnel endpoint over here at nsx-b. So that would cause the traffic to be encapsulated, sent over the Geneva tunnel, received here at nsx-b, who would then de-encapsulate it and forward it up to this VM who would receive it. And then if it's a ping request, there'd be a ping response, and the response would happen in the reverse direction. So here in the NSX manager, we're still currently at networking and network topology. Let's do a refresh. It should show us that we now have 2 VMs. And if we expand that, it should show us who those are. So there's the 2 tiny VMs, tiny on nsx-a and one on nsx-b. Fantastic. They're both connected to that logical overlay segment. And if we went back to our hosts by going to System and then under Fabric, clicking on Hosts, and let me collapse the left-hand column so we have a little more room here. And we expand our cluster where we are 2 nsx-i hosts. So sometimes it won't even show a tunnel as up. However, there could have been some initial broadcast or ARP requests that were done by our little VMs, and that would have caused the tunnels to be brought up. So if we click here on the tunnel for nsx-i, here it's showing us that we have a tunnel from nsx-ia's tunnel endpoint address, 10.11.11.151, and the remote side of that is 10.11.11.152, which is nsx-i's B end of the tunnel. And the encapsulation we're using is Geneva tunneling. And if we were to look at it from the perspective of nsx-i-b and click on the hyperlink here for the tunnel, it would think, oh, the traffic is sourced from my tunnel at 10.11.11.152 going over to 10.11.11.151. Another really cool tool here is under Plan and Troubleshoot. And we'll expand the left-hand column one more time. We can go to Traffic Analysis and check this out. There's a feature called Trace Flow where we can simulate what it would look and feel like if traffic is flowing from, for example, one VM to the other. So here we specify the details. It's using ICMP by default, very much like a ping would. And then we can specify a source as a VM. And let's select the tiny VM on nsx-a. So it's showing us the IP address and the MAC address there. And then we'll select for the target virtual machine, and we'll select the tiny on nsx-i-b. It's showing us the IP address and the MAC address for that VM. And then if we want to simulate and see whether or not that traffic would flow and how it flows, we simply click right here on Trace. Now in the background, what that's really doing, it's actually sending the traffic. And then it's taking a look and verifying whether or not it would make it and identifying all the logical nodes it would go through to make that happen. So the traffic is sourced from here, going over this overlay segment, going over to here. And then if we go for a play-by-play look, it's showing us here that the traffic went through a logical distributed firewall, which was permitting all traffic by default. It was then being sent over the transport network between these tunnel endpoints, which is between nsx-i-a and nsx-i-b, and then it was received by nsx-i-b, who then also processed it through a logical distributed firewall, where it was finally delivered to the destination. So this indicates that that traffic flow would work. So the real question is it really going to work? So let's head over to the little tiny Linux on nsx-i-a, and let's just confirm its IP address real quick. So that hasn't changed. It's 10.10.0.5. Let's do a ping over to 10.10.0.6, which is to the VM on the other host, and that's going to cause the traffic to go over the Geneva tunnel. So we'll press enter, and sure enough, that traffic is flowing. So that is one of the benefits of an NSX environment, is that we can stretch, if you will, a logical network segment and make it available. And those 2 nsx-i hosts don't even have to be on the same local subnet, but they have reachability via their tunnels to go ahead and reach each other. So as far as NSX goes, that is just the itty-bitty tip of the iceberg. Because not only do we have the ability to have these 2 VMs appear to be on the same segment, we also have, as you may have noticed in the trace flow, we also have the ability of micro-segmentation. So we could have these 2 VMs that have connectivity. However, we can have distributed firewall rules that are implemented by our host transport nodes that are controlling what traffic is allowed. And not only can we set up those firewall rules with the distributed firewall for traffic that's going between VMs on 2 different nsx-i hosts, we could also use those same firewall rules to limit the traffic flows between 2 VMs that are connected to an overlay segment that are both running on the same exact host. And that's where we get into the benefits of micro-segmentation and control, because we don't want these 2 VMs to be able to communicate. We can go ahead and use a distributed firewall rule and limit exactly what is or isn't allowed between those VMs. And that logic would apply to these 2 VMs if they're sitting right next to each other, being hosted by the same nsx-i host, or if we have communications between 2 VMs that are on a common overlay segment that are being supported by 2 different ESXi hosts. So in the next video, let me walk you through an example of setting up a very simple distributed firewall rule that allows us to control the traffic between 2 VMs that are connected to NSX segments. So I'll see you in the next video for exactly that.